In this discussion, we will talk about the interference due to light. From Maxwell's equations, it's known as that light is an electromagnetic wave. From Maxwell's equations are always look to see beautiful, but here I won't mention them. But what's the confirmation that we got from the Maxwell's equation as light is an electromagnetic wave? When light is an electromagnetic wave, it should show the interference pattern because interference is a property of waves. Now, here the question arises: how we can look for the interference shown by the waves? For this purpose, a man comes known as Thomas Young. Thomas Young, who given a very important experiment by means of which we can confirm that light it actually exhibits a wave character because it shows an interference pattern. How interference pattern is possible to the light waves? Thomas Young given an experiment known as Young's double slit experiment. The experimental setup of this experiment is very simple and straightforward. Let me just label it here. Suppose this is a slit 1 and this is slit 2. That's why it's named as double slit experiment. Here we also make the use of screen. The screen is meant for whatever result we want to confirm, it will give us a screen, isn't it? For example, a light ray, it just passes through this slit first. When it emerges out from the slit first, it will try to spread out like this way. What we expect from here that when it will spread out, it will just illuminate this screen. Instead, if we will use here the second slit also, by means of which the light is being emerged out and it will spread out in the same fashion. So what we will observe here, what we will expect here, this screen it should illuminate up to the good rate. But very peculiar thing is observed here that in the spite it should be illuminated up to the good rate, the bright and dark regions are being observed. The bands of bright and dark regions are being observed. Suppose this is a bright band, this is a dark band, this is bright and this is dark, so on and so forth. In quick succession, the bands are being observed. One among them is bright and one among them is dark, and so on and so forth. Now, what's the logic behind this? When we use the light just come out through the single slit, this slit second also, and the signal is sure to be illuminated effectively, but the presence of bright and dark bands are being observed. Suppose this is a bright band and this is a dark band. This is a bright band, this is a dark band. If we account the interference effect here, it's very easy to confirm this in that it's exactly the bright and dark regions are being observed by virtue of the interference effect. If we encounter the interference effect, that's the light rays which come out from the two slits, they interact, and this is because of that interference we just observe the bright and dark regions. And these bright and dark bands, they are collectively known as fringes. Fringes are just the notion for bright and dark bands. In a region, the bright and dark spots are being observed, and we call them fringe. When there is a bright band, we call it a bright fringe. Accordingly, when there is a dark band, we call it a dark fringe. Okay. Now here, how we can look for this thing that really the interference occurs? Actually, these are the bands which we observe from here. It's a clear confirmation that it's actually the interference of light. If it's really that interference effect takes a part here, then we know that the waves they interfere either constructively or destructively. We should figure out the conditions for constructive or the destructive interference in terms of this thing. For that, we have to look for the geometry of this experiment. If we try to demonstrate the geometry of the Young's double slit experiment, again we will use the two slits and screen. But I want to introduce sorry. I want to introduce the geometry of this slit experiment. Suppose this screen is at a distance L from the two slits, and the two slits they are at a distance D from one another. Means T is actually the inter-slit distance. When we make a transition to the geometrical optics, because I want to talk about here the geometry of this experiment. In geometrical optics, we use the light rays. We just show light rays by means of the straight lines. When we talk about the light ray, we use only the straight lines. Because in geometrical optics, we just diminish the wavelength of light. Means that the wavelength of light is being entirely lesser in character. So, in geometrical optics, it's the particle character that we try to figure out. And when the wavy nature of a given light ray just diminishes, so instead of wavy light, we will just use a straight motion here. Because in geometrical optics, we only mean for what's the geometrical heading of things and all that. See, if the light ray it just hits this edge here, and it will go this way. And here is another light ray like this. I showed here the straight lines. It's a notion for the two waves, because I just want to investigate here the geometry of a given experiment. In the geometrical optics, we use the light rays by means of a straight lines. Okay. If I will do a further construction, like if I will just draw the line here, it's a central line because it passes through the center of the intersecting distance and it just hits the signal at the center. Suppose this is the point which lies at the center of the signal. We just name it as a reference point. And if we if I will do the further construction, like suppose this is an angle theta made by the point P, where we just extend the line with respect to this central axis. And this angle is a relative angle here because it provides us the confirmation about where all the fringes are being observed, and it changes from point to point on the screen. So we call it a relative angle. Very important thing to mention. Look here. Now, as we just figure out this thing, that it's an interference effect by virtue of which the bright and dark periods are being observed. So we have to figure out, we have to look for the mathematical background about where are the what's the formalism for, or what's the formalism for the conditions of when the waves may interfere, that's what we are constructing. If you want to find, if we want to figure out the condition for constructing interference. Suppose let me draw the line here, which is perpendicular to this, and if this is theta, by usual triangle's property, this angle must be also theta. So the purpose of this thing of drawing this perpendicular here, that this ray, suppose this is ray R1 and this is ray R2. This ray R2, it actually covers the extra distance than this ray R1. Let me label it as here. There is an extra far distance covered by the ray second related to the ray first. So it means that R1 plus this gel must be equal to R2. And this gel, it is something R2 minus R1. Yes. This gel, it's R2 minus R1. This difference will give me the difference in the paths of ray second related to the first, and we call this gel as the power difference. Delta is the power difference of wave second related to the first. Now, if I will use here the trig identities, if this is a base and this will be a perpendicular, it must be the D side del will be equal to here R2 minus R1 with d sine theta. If I will introduce some more parameters here from myself, it's something equal to some number times lambda. What it means here that, see, if we look about this equation dimensionally, all trigonometric functions, they are unitless, means that here d, it's a dimensions of length, m is simply number, and lambda it has the dimensions of length. This equation has the correct dimensional footage, but what's the physics behind this thing? I need to look over that thing. See, when del is 0, when del is 0, means that R1 is equal to R2. This R1 is equal to R2. Means that whatever distance traveled by the wave first, it's equivalent to the wave second. What happens in this case? Let me see will it leaves the construct interference or not. If I would draw the wave first here, like this. Now, second wave, it will cover also the same distance. What happens in this case? The crest of one wave meets the crest of another wave. Now, this easily conforms the condition for the construct interference. When the crest of one wave meets the crest over the second wave, what results? Construct interference. Construct interference results if the amplitude of the certain wave is greater than the individual ones, isn't it? And we observe the same thing here because whatever distance covered by the ray first, same is ray second. In this regime, we find the condition of construct interference. So I use here something that del is some d sine theta, which is m lambda, while we call this m as ordinary number. Its value will be here 1, 0, plus minus 1, plus minus 2. For m 0, del is 0, no issues because it lives in the case of construct interference. Let me look about the when m is 1. So del will be equal to r the order of lambda. Means that the power difference will be equal to the wavelength of wave used. Suppose this is the first wave and this is the second wave. Here, it's quite rhapsodic. The waves are more or less symmetrical. In this case also, the crest of one wave it meets toward the crest of another wave. When this sort of happening occurs during the interference of waves, the construct interference results. Means that if the wavelength, if the power difference is of the order of wavelength of waves used, so what results? The construct interference. If we label all of the values here, we will get always the condition like the construct interference. So this condition, it's meant for the construct interference. When del is d sine theta is some order number times lambda, and m is some values like this, and in this degree we got the construct interference. Very important condition. So when we talk about when the construct interference will occur, one thing more here, when m is equal to 0, there is a formation of bright fringe because the construct interference results, and the bright fringe when m is 0 will be exactly at the center of screen because theta in this case will be 0. If this side is 0, d is not 0, means that theta must be 0. I told you as before, this is a relative angle, and this must be, this line, it should really coincide with this line, so it will give us the confirmation about wherever the fringe is being observed. Here it's meant for this condition we use here, it's meant for the constructed case, so bright fringe results, but this bright fringe exactly lies at the center of the screen, and we call it central maxima. Central maxima, or 0 order central maxima. 0 order central maxima or central maxima, this is one and the same. 0 order central maxima or 0 order central maxima. 0 order bright fringe or 0 order central maxima, this is one and the same. It's wholly conformable from the given from the given words here. Okay. Now let me look for the condition for when the destructive interference occurs. For destructive case. For destructive case, what will happen? What will happen here? See, when del is some d sine theta. Suppose I will just introduce a parameter here, lambda by 2. When the wave power difference of two waves is of the order of lambda by 2. Let me try to figure out what will happen in this case. See here, if I would just draw the wave like this, and another wave, means that I have to push backwards one wave with a character like this. It doesn't matter if there is a variation in the amplitudes of the two waves, doesn't matter because the whole, I need only one conformable thing, and that's if the crest lies, what will happen on the interaction during the waves, and what should be the structure of the resultant wave. See, if the wavelength is here of the order of lambda by 2, what happens in this case means that the crest of one wave, it falls over the trough of another wave. What results? Destructive interference. Means that the resultant wave has the magnitude in the very diminishing domain. See, this is a resultant wave and the crest follows over the trough of one wave. So resultant wave has the amplitude very less than the individual ones. So it purely confirms that when the crest of one wave follows over the trough of another wave, what results? That's a destructive interference. Means that if the spot difference is of the order of lambda over 2, so the destructive interference results. If I would generalize this above condition, if del is some d sine theta, it will be is some order number plus half of lambda, while m is 0 plus minus 1 plus minus 2, so on and so forth. When we introduce the values 0 here, lambda by 2, no problem for the destructive interference. If m is suppose 1, this del will be 3 by 2 of lambda, means it will be 3 by 2 of lambda. If we just try to utilize the same story here once again, we will again get the condition for the destructive interference. Just label it at our own places. It's a good exercise. So here we will again get the condition that's here in this case meant for the destructive. When d sine theta is m plus some half integral times the wavelength curve, we use it because when the two waves show the interference pattern, wavelength we use from the source must be monochromatic. That's not my discussion here, but when we confirm the wavelength of one wave, it's self-understood that in the problems when we try to do the things, when we try if the wavelength is given, we don't require for the wavelength confirmation for another wave, because in the interference pattern the source must be coherent and the wavelength come out from source must be monochromatic in nature. Monochromatic means single wavelength. There shouldn't be variation in the wavelength. It will lead to the variation in the phase, and we have the varying phase. That in that case we will never observe correctly the interference pattern, is it? Okay, let me do some simple problem regarding this concept. That see here. Let's suppose I'll just make the two income rays like this, and there's another ray like this. Okay, if I would draw the angle here, suppose it makes an angle theta 1, the d is usual, the slit distance between the two slits, and if the ray of light it comes like this, suppose this is a central angle here, central point here. What happens in this case here again, if I would draw the baseline here once more, this will be at theta 2. If the question asks us what should be the ratio of the two angles at which the constructive interference takes place, at which the constructive interference takes place at the central maxima. For the central maxima, what should be the value of central maxima? Yes, m is 0. The order number is 0 for the central maxima. So it looks a very simple and straightforward problem, but I need to confirm here. Suppose if I would draw the perpendicular here, this will give me the power difference from here to there. But if I would draw the perpendicular here, this is the power difference as I take usually in the double-sided experiment, but I need to take account this power difference here also. If this is theta 1, this must be theta 1 also, then this will be equal to d sine theta 1. If this is theta 2, this must be theta 2 here once more, then this will be equal to d sine theta 2. This is a usual power difference, but I have to subtract this much of power difference from here. Very important thing. Means that when I will subtract this much of power difference here, so what I will get under this situation, because this is a usual power difference, but I have to take account this power difference here also, because this is one wave here that travels ahead some that travels some extra distance when they meet the point here, isn't? So the net power difference will be equal to here, yes, it will be some d sine theta 2 minus d sine theta 1 will be equal to m times lambda, because the question asks us about what's the ratio of these angles at which the central maxima will be observed. For central maxima means that we have to take here the condition of interference. When we use the condition of interference, that's this, for the central maxima or zero order bright fringe, m should be 0 here, then this should be d sine theta 2, d sine theta 1, that will be 0. Means that d, it will be sine theta 2 minus